First of all, I would like to thank Eric for inviting me this morning for two reasons. Of course, because of the content of the seminar, but also because it gives me an opportunity to speak in front of my future colleagues in a couple of years. So we should start somewhere, one action, one fact, in direction to the origin of our institution. So let's come back to the topic of my talk. So I would like to draw some relationships between what we are doing and what are the opportunities for collaboration between visualization and what is around visualization and design sciences. Okay, this is the purpose of my talk. So what I'd like to do is that at the end of the talk you know what we do and what we might do together. If we can answer to this question, I will be successful in my talk. So, our mission. Some months ago we have decided to try to refocus, refine what we do in our institution, in my department, and to come with one sentence that could summarize what we're doing. So this is a sentence that is used now. So our mission is the use of computer science. All of us are computer scientists, so we are clearly IT/IS oriented. We want to ease the understanding of complex big data. Why? Because everyone knows that there is a huge amount of data produced every day in every very diverse context, from environment to management to finance to whatever. They come from multiple and heterogeneous sources, which raise some issue in terms of infrastructure, data access, and so on. We want to promote visual representation to help to understand those data that may be accessed via any type of devices, which open the ways to new development in hardware. For instance, iPad didn't exist some years ago. And in various contexts of use, which means that we are not focused on one industry. We are not doing IT for finance or IT for biology or whatever. So, this is the new chart that is used to explain first internally and now externally what we trying to do. We have identified 4 bubbles that represent 4 competencies that we have in our teams. We have some expertise in interactive visualization of data. Just to let you know what visualization means in this context, it doesn't mean visualization of buildings, of cars, of products, but visualization of abstract data. So this is the main difference, because most of the people think that when we are doing visualization, they think about CAD systems or systems used to support architects and engineers and so on. Another bubble is data processing, which encompasses topics like clustering systems and so on, so all the techniques to process and analyze data. The third one is data provisioning. So data are offered, delivered, accessed in various ways with various technologies, various architectures, and it's also something where we have some knowledge. And finally, we do not do only graphics on a sheet of paper, but we want to deliver software applications, so there are also some issues in this matter. So, what we try to do to be original is that we do not focus on the bubbles, but on the links between the bubbles. It is in the world, there are a lot of teams, larger than our team, that are working on one of the bubbles. That are experts in databases, they are experts in data processing and so on. But there are fewer people that are investigating the links between the bubbles. And that's where we want to focus on. And moreover, a very limited number of teams are gathering the 3 arrows in the same team, because the challenges are quite different in the arrows. Okay, so what does it mean? It means that, of course, as computer scientists, we need to have some competencies, some knowledge in all the domains of computer science, like databases, cloud computing, mobile computing, and whatever. But we do not do research in this domain. So we simply use state-of-the-art techniques in this domain. And at a larger scope, we do not have some people that do not, without a background in computer science or engineering. It means that we are not experts in economics, in finance, in physics, biology, or sociology. So, but of course, we collaborate, or we are open to collaborate with people from these fields, which bring their own expertise and which can lead to cooperation with on a specific topic. For instance, in biology, they have some visualization issue in biology, or in finance, or in history. We do something in history, but why not? So, just to elaborate a little bit about the arrows, we want to visualize more than data. We want to do more than pre-processing of the data, and we want to do more than graphics. What does it mean? More than data. What we want to do, and have started to do, is to combine in the same tools, in the same systems, the data provisioning issue directly in the tools. For instance, if you have graphics and the financial crisis that is not yet finished, fortunately, was a very good example of this. We had a lot of data with produced by very different actors with various degree of reliability, of disponibility, and so on. And they are progressively aggregated, and at the end of the day, you have one or two charts, and people in a room in one weekend should decide on things. Of course, the chart adds a lot of information. And it's a huge challenge to include at each aggregation level some meta information about the context of the data. And it's a challenge because on one way, either too much information, on the other way, information that is not available, for instance. More than pre-processing, usually speaking, and the first talk was a good example of this case, you collect data, you process the data, then you visualize the data. That's what we did in our practice. And what is an emerging topic is called visual analytics, which try to combine in the same tool, in the same moment, processing and visualization. It means that directly in the graphics, you can change, modify the process of the data, the parameters that govern the process of the data. Or, another topic, you can display the process, for instance, a clustering process, to be able to stop the process if you see that it doesn't deliver good results. Or you can see that you should exclude one or two outliers, and you see it visually. You can simply exclude the outliers and go on with the process. It means that you must break the usual sequence, process first, then display. And it's facing challenges, of course. And more than graphics, and it's also something that we have experienced in the past, that we also need better engineering approach to design visualization tools. And why? Because increasingly people are not demanding some one specific tool in one specific technology or platform, but when, for instance, new graphics are created, we should be able to deliver it on iPad, with Windows, Android, with Java, with blah, 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 blah. So we have to build some good models, some good software engineering methods that allow us to support the delivery of what the visualization people do on a large diversity of usage and context. So, what we do, so we want to better understand our world through visualization. And these are two examples of visualization that we have proposed. Only this, but all of this. Only this, meaning what I've explained in the slides before. We are not experts in finance, not experts in biology, not experts in sociology. But all of this, meaning that it's more than simply designing something on a whiteboard.